today's lesson is called implicit derivative. So implicit equation is a function with multiple variables. So there's two different type of equation. There's called explicit and there's something called implicit. The easy way to identify them is if you're able to rewrite the equation as y equal to or x equal to, in other words, as a single variable. So for example, let's say you're given x minus 5y equal to 10. We could rewrite this as x equal to 10 plus 5y. So this is known as explicit. But something like this, where x squared plus 4y squared equal to 3. Regardless of what you're trying to solve for, whether it's x or y, you're going to end up with two different equations. So 3 minus 4y squared equal to x squared. If you try to solve for the x, you will have two equations because when you take the square root of x squared, you're going to have positive and negative answer. So implicit derivative is used in these situations. So let's look at the example to see how we could use implicit derivative to find the derivative of a function. Example 1, find dy over dx. Okay, we learned that dy over dx is another way to say derivative. So dy over dx is another way to say derivative. Important thing you guys have to understand, the one in the numerator is your dependent variable. One in the denominator is your independent variable. Yeah, this is a key thing when you're taking the implicit derivative. So the first thing you would do is you're taking the derivative of each term. While you're taking the derivative of each term, whenever you take the derivative with the dependent variable, you're going to multiply by dy over dx. So we have 3x squared, so derivative will be 6x. Notice that we took the derivative of x, therefore we're not going to multiply anything. Next term, negative 4y squared. Derivative of that will be negative 8y. Notice that you took the derivative of y in this case. Y is our dependent variable, so we're going to multiply by dy over dx after. 2, derivative of 2 is 0. Again, we don't have a variable there, so you don't have to multiply anything. Again, so the key point is whenever you take the derivative of a dependent variable, you're going to multiply by dy over dx. So once we take the derivative, we're going to solve for dy over dx because we're looking for dy over dx. So we're going to try to isolate dy over dx. So negative 8y dy over dx is equal to negative 6x. Again, you're subtracting 6x to the other side. So dy over dx will equal to negative 6x over negative 8y. And if you simplify this, we get dy over dx will equal to 3x over 4y as our derivative. Okay, so let's look at the next example. So this one's a little bit more complicated because we have 3x over y squared minus 5x equal to 2y plus 7. Notice that 3x over y squared is a quotient, so we still have to use quotient rule. So whatever we learned before, it still applies here. So if you take the derivative of the first term using the quotient rule, you should get 3 times y squared minus 2y times dy over dx times 3x all over y to the 4th. Again, notice that you took the derivative of 3x, which is the x, that's why they multiply by dy over dx. But in the second term, we took the derivative of y squared, which we get 2y, And in this case, we took the derivative of y, that's what we followed up with, dy over dx. So minus derivative of 5x is 5. Again, we took the derivative of x, so we don't have to follow with anything else. Equal to derivative of 2y is 2, but we took the derivative of y, therefore we have to follow with dy over dx. And derivative of 7 is 0. Now we're going to try to isolate and solve for dy over dx. The first thing I'm going to do is I'm going to try to get rid of this denominator, so I'm going to multiply the entire equation by y to the 4th. So the first term in this case, your denominator will disappear, leaving you with 3y squared minus 6xy dy over dx minus 5y to the 4th, because you need to multiply to this term, equal to 2y to the 4th dy over dx. Now I'm going to isolate the dy over dx. So I'm going to try to move it to the left side and move the other terms to the right. So we have negative 6xy dy over dx minus 2y to the 4th dy over dx equal to 5y to the 4th minus 3y squared. Again, if you want, you guys could have solved it as to the right side for dy over dx. I'm just comfortable solving as the left side of it. That's why I moved it to the left side, but that's your choice. So now we have dy over dx in both sides of the equation, on same side of the equation. So I'm going to factor them out because that's the common term. And last thing we have to do is divide it to the other side, leaving you just with dy over dx. In this case, I see that y is in every term, so I'm going to factor out y and divide it out. So your final answer should be 5y to the 3rd minus 3y all over negative 6x minus 2 times y to the 3rd will be the answer. So as a conclusion, implicit is used when you have multiple variables. And to solve for the implicit, you will follow these steps. First, identify your independent and dependent variable. Take the derivative of each term. Multiply the dy over dx after the derivative of dependent variable. And then solve for dy over dx.